Hello. So this video is going to tie together a couple different things, some stuff about music, some stuff about electronics. What this whole video is I have a setup here. I just built a battery box for the Zendrum. The Zendrum is this instrument right here. If you've never heard of the Zendrum, check out Zendrum.com. A very, very, very cool MIDI instrument controller. And I make this battery box for the Zendrum, and this is it right here. And it's all hooked up and everything, powering the Zendrum. And I have this little MIDI module here. It's called the MIDI Plus. And basically, the Zendrum is a MIDI controller. It's got 24 touch-sensitive pads on it, and you can program the pads to be whatever sounds you want. And I'm testing it right now with the battery box. But one thing I did that I wanted to show was I have it hooked up. The battery box, the sound module, but I also have it going over here to a Radio Shack color computer that I bought in the 90s that I really like a lot. My background's electrical engineering, and I really got into a type of programming called assembly language programming, and this particular computer has a Motorola 6809 that was used in a lot of products at the first company I worked at. So what I did here was when I was working on making a MIDI controller, and I made this MIDI interface. That's what all this stuff is right here for the color computer, and it's plugged into the what's called the game port or the accessory port, and all this circuitry here basically allows me to receive MIDI data and then send it to a TV set. This is the monitor for the computer, and what's on this board right here for all you engineers or people that are into electronics, there's some TTL logic, and there's a UART chip here, and there's two crystals, because this board can work with MIDI data, and it can also work with RS-232 data, and it's running a program that is stored in this EEPROM right here. Okay, so I got some manuals for the color computer, and was able to figure out how to write some software to basically receive MIDI data and then convert it into printable characters that would show up on the TV here. And I use this a lot for testing and development and debugging. So what's over here on the TV is basically the program which I wrote. And I'm going to hit the number 2 key, which will make it receive MIDI data and basically display it on the screen. So let me do that right now. Okay, so if I hit a pad, okay, so what you're seeing is the actual MIDI data. I'm going to hit one pad soft and hard, and then I'll kind of explain what the MIDI data is. So okay, so I hit this pad about 4 times. So the very bottom line, if you look at that, it says 99, 24, 35, 24, 0. So this is the MIDI message that's sent out when you hit the pad. The 99 is a note on message on channel 10. In MIDI data channel. The channels are numbered 1 through 16. Channel 1 is actually number 0, so channel 10 would be number 9, so that's why it's 99. And then the 24 is the note number, so it's a note 24. 35 is the velocity, so I hit it with like a fairly soft velocity. It's a number 35, and then the 24 is the note again, and the 0 is a velocity of 0, which means stop playing that note. So with percussive sounds, you don't really notice notes which are held, because all percussive sounds are short in duration though. So I'm going to tap this soft, and you can see the velocity, that third number, that third byte is fairly low. If I hit it really hard, then it's the numbers go up, so it's a larger velocity. So anyways, for all you that are interested in MIDI communication, that's a little bit of an overview there. So basically, that's just kind of a little simple setup that I have here. It kind of ties together elements of music, elements of electronics, and hope you find this interesting, and thanks for watching. Bye.